Today, I want to take you through a small pivotal moment in my work with Vitality. A moment where the true potential of open cognitive architectures really hit home for me personally. This isn't just about running a query. Rather, it's about seeing how open architectures like React can give us both flexibility and deep insights into the AI's decision-making process. By the end of this video, I hope you'll see how cracking open that black box of AI can reveal the full potential of what this technology can do. Let's dive in. Let's start by breaking down the query we're going to run through Vitality. This query is all about getting a clear picture of my running performance over the past year. Specifically, I want to know how many miles I ran in total in the past year. What was my longest run? How many calories did I burn on this run? And whether that run burned the most calories across all my workouts. Now, this is the type of question I always find myself asking at the end of the year when I'm reflecting on my fitness progress and setting new resolutions. It's something that should be simple, but seems to be always painful to track down in Apple Health. Now, the query itself is a multi-hop, meaning it has 4 distinct parts. The first 3 can be answered by calling our health endpoint actions in parallel, while the 4th depends on the result of the 3rd. So, we're looking at a mix of dependencies and optimization opportunities that a well-architected AI agent can really leverage. Now, let's bring up Vitality AI on ChatGPT and run this query. As we do this, I'll be showing you 2 windows. On the left, we have the ChatGPT interface, and on the right, we've got the semaphore action run view. This will remain empty until the query starts executing. But before that, let me quickly show you the list of action health endpoints we have available. Now, these endpoints cover various health data entities, from medication records to different workout types, lab results, clinical notes, and more. These are the building blocks that Vitality AI uses to answer health queries. Now let's execute the health workout query in Vitality AI using CustomGPT. As the query runs, notice how the actions are being invoked sequentially in the actions run view on the right. Now here's the final answer provided by Vitality. It accurately answers all 4 parts of the query: the total miles run, the longest run, and the calories burned during that run. And as you can see here, there was another workout, a walking workout, that actually had the highest calorie burn. But if you look closely at the actions run timestamps on the right, we see that each action was called sequentially, one after the other. This is where the limitations of CustomGPT closed architecture come into play. Now, let's bring up Vitality on OpenGPT with the Open React Cognitive Architecture. Here, we've got 3 windows open instead of 2. On the left now is OpenGPT with 3 Vitality agents running, each with a different cognitive architecture. In the middle is the actions run view, and on the right is LangSmith from LangChain, which gives us a detailed trace of the agent's LLM and action calls. Now, as we run the health query, we'll see each step and its corresponding trace in real time. Now, let's select the React Vitality agent and run that same workout query. As Vitality processes the query, watch how the actions populate in the actions run view and how LangSmith captures the detailed trace. Here's the final result. All 4 parts of the query are answered and match our previous answers from Vitality on ChatGPT, but with one critical difference. Let's take a look at the actions run view. Here, we observe two sets of actions executed simultaneously due to their dependencies. The timestamps confirm these parallel calls for these two groups. This is the optimization that React allows. Now, let's dive into LangSmith, where we can see the detailed trace of how the React architecture processed this query and invoked these actions. Here, we see the agent call the LLM 3 times. Let's take a look at the first LLM call. In this first call, the LLM identifies 3 specific actions to address the first 3 questions in our workout query. 1, total miles run last year, 2, the longest run, and 3, the calorie count for the longest run. And here's where the React architecture really shines. It enables the agent to execute these actions simultaneously, optimizing the process and saving valuable time. Now, let's take a look at that second LLM call. Here, the LLM identifies that to answer the 4th question, determining which workout burned the most calories, it needs to calculate the max calories burned across 5 different workout types. And just like before, the agent efficiently executes these actions simultaneously. And in the final LLM call, it summarizes the answers from all the actions. So there you have it, running the same query on 2 different architectures, one closed and one open, showcases the unique advantages of open cognitive architectures. They not only allow for optimizations like parallel action calls, but also give us the ability to see how the actions are triggered and decisions made, effectively cracking open that black box. This transparency is what makes architectures like React, powered by LangGraph, so powerful. It's not just about getting the right answer. It's about understanding how we got there. And that, to me, is a small agentic aha moment.